So I got some good news and I got some bad news. And then I got some really bad news. Okay? Good news is that you have this problem done already because you did it last night, so I can go through it rather quickly. Bad news is that the test is going to be next week, Thursday, on this stuff. Okay? See, you were supposed to be one of those DECA people that I was supposed to get something for. Back when I asked, is there anybody that's going to DECA next week? Really bad news is that on May 6th and May 7th is going to be your NTC final.
Whoa.
Okay? Yeah.
That's like on Friday.
No, that's a 4-mod day. 6 and 7.
That's like in 2 weeks.
Yeah.
Cheapers.
Yeah. From 2 weeks from this past
Yeah.
Monday, Tuesday. Yeah. Okay? So just so you know, you got that going on. And then at the end of May, then we'll take a Wausau School District final too. So really, really bad. Everyone. Oh, we got stuff. All right. All right. So, from yesterday, come on. Okay. So, from yesterday, we should have found that z sub 1 in trig form was 5 times the cosine of 306.9 degrees plus I times the sine of 306.9 degrees. And that z sub 2 was 6 square roots of 2 times the cosine of 315 degrees plus I times the sine of 315 degrees. Is that what everybody got for those two in number 6? If not, that's what you should have gotten. Okay? Then yesterday we realized that it was much easier to multiply both in trig and in standard form. And so in trig form, this one here, the multiplication would be, oops, I got to put it in this color, would be 5 times 6 square roots of 2 times the cosine of 306.9 degrees plus 315 degrees plus I times the sine of 306.9 degrees plus 315 degrees, which gives me 30 square roots of 2 times the cosine of 621.9 degrees. But what's the problem with that one? I mean, I like it and all, but it just looks weird. Why does it look weird? So that angle's outside my first lap around the unit circle, right? Or around the circle. It's the second lap around the unit circle. Did you want it?
No.
It was in your head, so that's why I was asking. So how am I going to get it back into that first lap? How would I get 620? I would subtract 360 degrees from it. So the trig form here of this one would be 30 square roots of 2 times the cosine of 261.9 degrees plus I times the sine of 261.9 degrees. That would be trig. Standard, if we actually multiply them out, would be -6 minus 42i. And you could also get that by distributing 30 square roots of 2 and then multiplying it by the cosine of that. Dividing wise, we would have z sub 1 would have been 5 as my radius. 6 square roots of 2 was the radius on z sub 2. And then we'd have cosine of 306.9 minus 315. Both of those were in degrees. Plus I times the sine of 306.9 minus 315. Okay. And so that one, do I like the fraction 5 over 6 square roots of 2? Why not, Brooke? Yeah, we don't like the square roots on the bottom. So I'm going to multiply that one by the square root of 2 over the square root of 2. And then here I get negative 8.1 degrees. And what don't I like about that one? It's negative. So how do I make it positive? How would I make negative 8.1 degrees positive? So just add 360 to it? Yeah, so we could just add 360 degrees to it, okay? And so then that would be the trig form, would be 5 square roots of 2 over 12 times the cosine of 351.9. And then the standard form I want to say is something over 12. Like 5 minus 7i over 12, I think, something like that. Anybody do the standard form?
7 minus I.
7 minus I over 12?
Yeah.
That one? Yeah. For the divide? Okay. Okay, so we got that. Now, my question to you is this. What if we got something that looks like this? 2 minus 2i square root of 3 to the 5th power. This is straight up in your notes now. Yeah, you're on your own for notes for today. Okay? So, contrary to popular belief, okay, I'm going to go a little bit off to the side here for a second, and I'm going to say that if we have x minus y, and I take that to the 5th power, the majority of people, and I would probably even guess that some people in this very room think that that is x to the 5th minus y to the 5th. Okay? But what really is it? When I say x minus y to the 5th power, so it's x minus y times x minus y times x minus y times x minus y times x minus y, right? So it's all of those, right? And you thought I wasn't going to have enough room. Not my first rodeo. Okay? With me? Okay? So if I've got 2 minus 2i times the square root of 3, and then I've got that, all of that to the 5th power, what that is saying is 2 minus 2i times the square root of 3 times 2 minus 2i times the square root of 3 times 2 minus 2i times the square root of 3 times 2 minus 2i times the square root of 3 times 2 minus 2i times the square root of 3. Right? 5. Okay? Now, yesterday we found that in some cases it is much easier to first change it into trig form and then multiply the complex numbers. Yes? Because me personally, we would have to do 2 of these at a time. So I'd have to do these 2, and then I'd get a binomial. Right? And then I'd have to do these 2, and I'd get a binomial. And then I'd have to do these 2 and get a binomial. And then I'd have to do these 2, and then I finally get my answer. Because I can only do 2 at a time. Right? Okay? So that might not be the best thing for us. So let's change this over into trig form first and see what we can do from there. Okay? So I need to find my r value. What is r to get it into trig form? Square root of a squared plus b squared. So that's going to be 2 squared plus negative 2 square roots of 3 squared. And then I'm going to take the square root of all of that. 2 squared is 4. 2 square roots of 3 squared is, what do you got? 12. Yep, 12, because it's 2 times 2, square root of 3 times the square root of 3. So it's 3 times 4, which is 12. 4 plus 12 is 16. Square root of 16 is 4, correct? Okay. Then we got to find theta. My question to you is this. In the complex plane, where does this complex number fall? Which quadrant? Quadrant number 4, because it's positive a and negative b. So that's quadrant number 4. So the theta that I find is really a reference angle. So it's really a theta prime. And that's going to equal the inverse tangent of b, 2 square roots of 3 over 2. Now, one thing that I've noticed, especially on the last test, was that we are struggling with typing that into a calculator. And so before we type that into a calculator, let's do some simple math first. Can that fraction be reduced at all? Yes, to what? It's just the square root of 3. So let's reduce that because that's an easy reduction. And now, tangent, that is the square root of 3, that should pique my interest because do I even need to use a calculator on this one? No. What's the angle for it? 60 degrees. Yeah. So my reference angle is 60 degrees. Now, we said that this angle lies in quadrant number 4. So my actual theta is going to be what? 300 because it's 360 minus my reference angle. So my actual theta is 300 degrees. So the trig form of this complex number is 4 times the cosine of 300 degrees plus I times the sine of 300 degrees. Right? And that we are going to take to the 5th power. Right? Which means multiplying in trig form, I'm going to take 4 times the cosine of 300 degrees plus I times the sine of 300 degrees times 4 times the cosine of 300 degrees plus I times the sine of 300 degrees times 4 times the cosine of 300 degrees plus I times the sine of 300 degrees times 4 times the cosine of 300 degrees plus I times the sine of 300 degrees times 4 times the cosine of 300 degrees plus I times the sine of 300 degrees. Right? Okay. And if I'm multiplying in trig form, what am I going to do with all those r's? Multiplying in trig form. What do we do with the r's? If they're all in trig form. Multiply them all together. So that means that I'm going to take 4 times 4 times 4 times 4 times 4. Right? And what am I going to do with all the angles, all the thetas? I was worried that I wasn't going to fit it in. I think I got it. Right? So, what is 4 times 4 times 4 times 4 times 4? What you got? 1,024. What is 300 times plus 300 plus 300 plus 300 plus 300? 1,500. My question to you is, do I like that answer? Why not? 1,500's outside my laps, right? Outside my first lap. Okay? So how do I get it down to inside that first lap? Subtract 360. So if I subtract 360 once from 1,500, I get 1,140. Still outside my range, right? If I subtract it twice, I get 780, right? If I subtract it 3 times, I get 420. Excuse me. And if I subtract it one more time, 4 times, I get 60, right? Excuse me. So this is really 1,024 times the cosine of 60 degrees plus I times the sine of 60 degrees. And if I needed it back in standard form, I could just distribute that. Okay? Right? Okay? But it didn't. It just said give us the, I think it just said give us the if I go back up here to this step right here, I would say to myself, self, can I make that first blue step, can I make that be any cleaner? This blue step right here. Can I make this first blue step right here, that one, can I make that be any cleaner? What do you got, Will? Okay, so this right here is really 300 times 5, right? Okay, that's one way to make it cleaner. Then this right here is 4 to the 5th power, right? Okay. And that, ladies and gentlemen, is what is called de Moivre's theorem. De Moivre's theorem says that if you're taking a complex number in trig form to a power, all you have to do is take the radius to that power and multiply the angle by that power. So de Moivre says we need to take the radius to that power and then multiply the angle by that power. So if I have negative 3 plus 3i to the 4th power, I could go negative 3 plus 3i times negative 3 plus 3i times negative 3 plus 3i times negative 3 plus 3i and get a lot of I squareds and a lot of confusions and binomials and okay? Or I could change this over and I could say that r here is the square root of negative 3 squared plus 3 squared. That's 9 plus 9. That's the square root of 18. So that gives me an r value of 3 square roots of 2. Agree with that? Okay. I could say that this gives me a reference angle of 45 degrees, because that's where tangent is equal to 1. And since this point lives in quadrant number 2, my actual theta would be 135 degrees. Which means that the trig form of my equation is 3 square roots of 2 times the cosine of 135 degrees plus I times the sine of 135 degrees. And that I need to take to the 4th power. Which means all I've got to do is 3 square roots of 2 to the 4th power times the cosine of 4 times 135 degrees plus I times the sine of 4 times 135 degrees. Three square roots of 2 to the 4th power is like 3 times 3 times 3 times 3, which is 81, times the square root of 2, which is 81 square roots of 2, times the square root of 2, which is 162, times the square root of 2, which is 162 square roots of 2, times the square root of 2, which is 324. 4 times 135 degrees is 540 degrees. But I don't like 540, do I? Outside my first lap. So this would be 324 times the cosine of, I think it's 180, right? And again, if I need to change it over into standard form, I could just distribute that 324 into it. Okay? And I'd get negative 324 plus 0i. Okay? Have yourselves a great, grand, and wonderful day.